for support among my fellow astronauts in the NASA organization. Air Force helped a little bit. I had been a part of this period, a dark, troublesome time. My family life was impacted. My marriage ended in a divorce. Looking back, I lost nearly a decade of productivity in a downward spiral. Ultimately, I chose the road to recovery. By 1978, I'd taken my last drink, and today I have 34 years of sobriety. It took me a while.
Bravo. Bravo.
I still get depressed, want to hide, escape, pissed off at the world. But it took me a while to realize the one thing that I'm most passionate about is space. And that's where I should once again direct my efforts. Pretty much as an individual, little time with this company or that company. And so I might as well use my fame and influence to help raise awareness and advance the space program to get us on a forward track and on to Mars. So that is where my focus is. Mars. I've always felt that that should be the next destination, following our landings on the moon. We can't ignore the moon. We can help other people, especially if we're not going to land. We're the ones, naturally, to bring together the rest of them. And I've been very vocal about this for a long time. But the dream of reaching Mars looks like it's finally getting closer to reality. With the Curiosity rover now on the surface of Mars, showing us more than ever before, I'm hoping it will pique the curiosity of young people like you around the world with the idea of exploring beyond Earth and Moon and on to Mars. Permanence on Mars. Obviously, I'm very passionate about Mars and forging our future in space. People ask me all the time, why do we need to go to Mars? Or why do we even need a space program? Because by venturing into space, we improve life. Innovation, technology. We improve life for everyone here on Earth. The scientific advancements and innovations that come from this type of research creates products and technology that we use in our daily lives and provide even more convenience for people all over the world. Cell phones, I got two. GPS, TV, all of these wouldn't have been possible without the investments in our space program. So how do we get people excited about space again? And the big question is, how do we get there? We need a plan. We also need a leader in the world to state a public goal with a specific time. I've got an idea about how that should happen around the 50th anniversary of our moon landings. But I have also laid out a plan in my new book, Mission to Mars, published in early May by the National Geographic Society. They picked the title. Turns out that Mike Collins wrote a book with the same title, and there was a movie that wasn't exactly a smashing success. But it got me the rights to my science fiction story back again. Now, I had wanted to just change the title. One letter. Just add an S. Make it Missions to Mars. It's not just one expedition. It's a vision. And I wanted it to be called missions to Mars, because we're not talking about one trip, we're talking about multiple missions, eventually to settle and colonize Mars. Years ago, 1985, I devised a method of cycling orbits, continuous trajectories, first between Earth and the Moon. Probably wouldn't be better if your purpose was to land on the Moon. But it would be great for tourists, either flying by the backside or the front side. But NASA wasn't interested, so I was asked by the administrator at NASA when we went to the Moon, let's look at Mars. So back in the early 1980s, I applied my orbital rendezvous experience to this cycler system that transfers every other opportunity. The opportunities to go from Earth to Mars are 26 months. So every other is about 52 months. And perpetual cycling orbits between the Earth and the Moon. And here, the blue line is the Earth, the red is Mars, and the green is the Sun, and the little green is the spacecraft. And central to the idea is using the relative gravitational forces of the Earth and the Moon or Mars to sustain the orbit, thereby expending little fuel. And it's called gravity assist. But there was a catch. For the Moon, it took longer to come back and have an opportunity to do it again. A 4-day trip using lunar orbit rendezvous was still the best thing to do. So NASA said, go away, don't bother me. But it was my good fortune. A friend of mine, Tom Paine, the administrator of NASA, during a number of the early landings on the Apollo expeditions, including ours, he urged me to adapt a cycling orbit concept to Mars, Earth and Mars. And I did that, and it looked pretty good. But it's even better now because working with Purdue University, we've developed every other opportunity, so you need 2 cyclers. And I love to invent and name things. So I'm calling the first cycler Armstrong and the second cycler Conrad, who commanded the second landing on the Moon. But more recently, and with the help of my interns and NASA colleagues a little bit, there's another way of describing this. When you see this in motion, I guess we're not going to push the button to do that. You can't do that, Christina? Can we do something to get that in motion? Okay, we just made the first transfer, people got off. Now we go out again, a little bit beyond Mars. Now, right here, we're going to swing by the Earth, and it's going to take energy out of the orbit. And now, a year and a half later, it's 1 year, year and a half, back into position to make a transfer back to Mars. Really neat, because what it means is that you got an Earth flyby, a year and a half later, you fly by the Earth, and you go to Mars. Then you come back and repeat that same cycle, so that the 2 Earth passes, a year and a half apart, allow you to add more supplies or help build the spacecraft. Now we've got another plot, the next slide, that shows the radial distance from the sun. And the sun is down here somewhere. So 0, and we get up to 1, which is 1 astronomical unit. And Mars is 1.52. Now, these are approximations, but damn good to kind of work with. They're circular orbits, coplanar. Earth is pretty circular, but Mars, a little bit out of plane, and it's elliptical. And I believe that we can get there between 2035 and 2040. So we have Aldrin Mars cycler, and this is the Purdue Aldrin cycler. I won't go into the details about each component. Here is a rendition of the cycler with 2 interplanetary spacecraft put together, because it works out okay. I'm looking at 3 right now. This was done for a video game, Buzz Aldrin's Space Program Manager. So I am not going to go into details. A lot of this was taken from what a Houston Johnson Spacecraft Center mission to an asteroid would look like. And the ideas, even before that, go back to a concept of not putting everything in one big thing, but 2 medium and then letting one grow bigger and the other smaller. So we want a small and then a medium large. And all this will probably change somewhat, but as new technologies. But the basic idea, I feel pretty confident, is an improvement over other competitive ways. We make an investment early on, we test it unmanned, and we verify that things are going to work out right before we send people. Once they land. Well, before they land, we want people, astronauts, but 3 of them to occupy the moon of Mars, Phobos, and put together things that are landed with longer term, more efficient cargo missions. A little over 2 years to get there instead of 5 or 6 months. And different objects will land in different places. How are we going to learn how to do this? These are big objects, and they can't be right next to each other. We've got to move them together and fix them so that people can go from one to the other. Electricity, fluids, and all the necessary things. How are we going to learn how to do this? Well, we better do this at the moon, even though we, the United States, is not going to land there. We're going to build and maybe put the first object down and learn how to do that. How are we going to learn how to do it at the moon? The big island of Hawaii is a wonderful simulated lunar terrain. So we can make a lot of mistakes there, controlling it via satellite from Houston to Hawaii. And you do it on Earth, do it at the moon, for other nations to use, not the United States. We're contributing the robotic stations that'll look for science, commercial activities, fuel depots, and will help construct the base. Not the expensive things of big rockets and landers and then continuing to supply people. So I will have a lot of updates about my USV, Unified Space Vision, on my website, www.buzzaldrin.com. As new technologies emerge, and I'll try and keep this up to date. And don't forget, you've seen the movie Toy Story?